Hello, welcome to the third lecture of rotational dynamics. In last video, we have studied uniform circular motion and non-uniform circular motion, centripetal force and centrifugal force. Today we are going to study application of uniform circular motion. There are two types of curved road. First, horizontal curved road or unbanked curved road. For example, racing track of runners. Second, bank curved road. In this type of road, suppose this is your original road. Okay, for example, this is your original road. This one will be inner edge of road and this one will be outer edge of road. So what happened in this case? That outer edge is raised by some angle theta. What does it mean? This road surface will going to be make some angle with inner surface. So it will be look like this. So this would be theta and this will be height. So in bank curve road, outer edge will be raised by particular angle theta. We will study it one by one. So let's firstly study vehicle along horizontal circular track. Consider vehicle of mass m on horizontal circular track. So this is top view of your circular track. So what we are going to consider? We are going to consider a vehicle of mass m which is moving along a horizontal curve road of radius. So this would be center and center of that vehicle to the center of circular track, it will be radius. So to have that mathematical expression, we will consider only this part. Okay, we don't need to care about this part. We have to just formulate that mathematical expression. So we will consider this part. It will be look like this. So we are considering only this part. So as this is a part of circular track, so this will be your center of curvature, as we are considering the part of that circular track, and this will be radius of curvature. What is that? Radius of curvature. Let v be the speed of the vehicle for curved road. So that speed can be shown like this. So v will be speed of the vehicle. For circular motion, we need centripetal force. So the necessary centripetal force is provided by force of friction between tires of the car and the road surface. So let's consider vertical section of a car on a horizontal circular track of radius r. So this is vertical section of a car on horizontal circular track. Here plane of figure is vertical plane perpendicular to the track, but include only center of the track. So this dotted one will be vertical plane perpendicular to the track. Now let's find the all forces acting on the body while performing circular motion, that is free body diagram. So vertical forces acting on body will be like, so due to gravity, weight of mg of the car is acting vertically downward. So it will be from the center of this point. So it will be vertically downward and through the center of gravity. So here W will be given by mg. So this gravitational force is acting on body, that's why we are getting weight mg. So according to Newton's third law, that there is an equal and opposite reaction. So due to this surface, the reaction force will be normal. So the normal reaction of the surface of the road on the car will be given by N. Normal reaction is the force exerted by surface on an object in a contact with it, which prevent the object from passing through the surface, and this force is perpendicular to the surface. That's why we are getting like this. And it is only the force that surface exert on the object in the absence of frictional force. Or you may consider simply like this: if this is the cardboard and if I am putting some object on this, now this cardboard has some capacity that is opposing to this object. That cardboard is exerting same amount of force which will require two object will fall down. So the force exerted by this cardboard on this object will be normal reaction. So now we have resolved what kind of vertical forces are acting on this body. Now we are going to resolve horizontal force. But before going to resolve horizontal forces, we will form the mathematical formulation for vertical force. So as the vertical acting force's normal reaction is a reaction of gravitational force and it is given by N. So vertical upward that balance the weight mg, so it will be given by mg is equals to N, or you may simply write N is equals to mg. You may write this as the equation 1. Now let's find horizontal forces acting on body. Force of static friction between the road and tire is given by like this. So this direction will be force of static friction between a road and the tire. It prevents the vehicle from outward slipping or skidding, because as we know velocity is what? Tangential. So if friction is not suitable, so instead of following circular track, a circular path, it will follows like this. What does it mean? It will follow linear path, and so on it will go out of the track. So this is a resultant force which is centripetal force. So that can be given by Fs is equals to mv square by r, because centripetal force is given by mv square by r, or you may write mr omega square. So you can consider this as the equation 2nd. So this one will be our free body diagram. This one will be center of curvature, normal reaction, weight mg, and frictional force. So while working in the frame of reference attached to the vehicle, it balanced centrifugal force. Okay. So now divide equation 2nd by 1. Divide equation 2nd by 1. So you will get Fs by N is equals to mr omega square divided by mg, which is equals to m and m will going to be cancelled, so it will be r omega square by g, or Fs by N is equals to mv square by r divided by mg. mm will going to be cancelled, v square by rg. So these are two alternatives you are going to get after dividing 2 by 1. For a given track, radius r is constant. For given vehicle, mg, which is weight of the vehicle, which is equals to normal reaction, is constant. Thus, as the speed increases, the force of static friction also increases. However, the value of static friction of any body is fixed. It means Fs that is, static friction has upper limit. So as you know, force is directly proportional to force is directly proportional to normal reaction. It will be given by Fs is directly proportional to n. So whenever there will be proportionality sign, it will be replaced by constant. So it will be given by mu s n. So here mu s is nothing but coefficient of static friction. So you have one relation, Fs by n is equals to v square by rg, and Fs is equals to mu s into n. So from this equation you will get Fs by n is equals to mu s. When you are going to compare these two equations, you will get v square by rg equals to mu s, or v square is equals to mu s rg. At maximum possible speed, Vs will be given by Vmax will be given by under root of mu s rg. This expression for optimum or maximum speed of the vehicle on horizontal curved road. The optimum or maximum speed of vehicle depend upon the following factors. Which factors? That coefficient of static friction, radius of curvature of the road surface, acceleration due to gravity acts on the vehicle, and it is independent of mass because there is no any mass factor in this relation. The speed of the vehicle remains the same for heavy or a lightweight vehicle. In discussion till now, we had assumed the vehicle to be point. In reality, if it is a four-wheeler, the resultant normal reaction is due to all the four tires. Normal reaction at all the four tires are never equal while undergoing circular motion. Also, the centrifugal force acts through the center of mass, which is not at a ground level but above it. Thus, frictional force and the centrifugal force results into a torque which may topple the vehicle. For two-wheeler, it is must for rider to incline the respect to the vertical to prevent toppling. Now let's move toward another application, that is well or wall of death. You may aware about this as the name मौत का कुआं. If you have ever gone to circus, if you could remember, there is a term like मौत का कुआं in which a stuntman performs circular motion. So that thing we are going to study in this part. So मौत का कुआं is a vertical cylindrical wall of radius r, inside which a vehicle is driven in horizontal circle. So this is side view and this is top view. So in side view you will get that vehicle performing circular motion. So let's draw some image of that car. So this will be side view. This vehicle will going to perform circular motion under cylinder. In terms of top view, you will get image like this. And this will be center of the cylinder, and the distance from the center of the vehicle will be radius of curvature or simply radius. So this can be seen while performing the stunt. This vehicle actually performing circular motion. So what could be the possibly provide the required centripetal force? Well, it has got to be normal contact force between the vehicle and the wall of the cylinder. So we know that the wall exerting normal contact force onto the vehicle providing required centripetal force. But what is the force is balancing the weight? So here it will be mg will be weight of the vehicle. But what is that which is balancing the weight of the vehicle? It can only be the frictional force, right? So here comes the question, what is the then when velocity of car is 0 or less, the frictional force will not be large enough to balance the vehicle weight. But if velocity of vehicle will be maximum enough, then the friction will be strong enough. Now let's form those two equations which will define this circular motion. So horizontally we know that net force required to centripetal force, so normal contact force providing required centripetal force, which we write as centripetal force, will be equals to, as we know that, mv square by r, or mr omega square, which is equals to n. So that normal contact force is providing required centripetal force. So you may write this as the equation 1. Similarly, vertically the force should be 0, so that upward friction must be equal to downward weight. So vertically upward friction must be equals to downward weight. So Fs, which is frictional force, will be equals to mg. So write it as equation number 2. Do you know that frictional force is actually directly proportional to normal contact force? As we have studied earlier, that frictional force is directly proportional to normal. So by changing the proportionality sign by some constant, you will get F is equals to mu s n, where mu s is coefficient of static friction, which is constant between two surfaces. In order of a friction to be large enough, so we need the normal contact force to be large enough, which means we need the angular velocity to be large enough, so vehicle must be moved fast in a circular path enough before the frictional force can be large enough to hold the weight of the vehicle. Therefore, force of static friction Fs is always less than or equal to mu s n. That is, Fs less than equal to mu s n. So you will get from equation number 2, mu s is equals to mg. So you can write Fs as a mg less than equal to sign as it is. Then from this equation you can find n is equals to mv square by r. So write down mu s as it is, and n is equals to mv square by r. So m and m will going to be cancelled. So g less than equal to mu s v square by r. So r will go this side, mu s will go this side. So v square greater than equal to rg by mu s. So the minimum velocity which can hold the frictional force will be V min will be equals to under root Rg divided by mu s. Some student will ask, why should normal contact force increases as the vehicle spins faster? The answer is, cylinder just trying to stay in. The cylinder is just trying to stay intact. If it doesn't keep the vehicle going in a circular motion, he must be mean the vehicle crashed through the wall of the cylinder. So the cylinder was keep its molecular structure. So he will just exert right amount of force to keep the vehicle going in circular motion rather than crash through it. In this case, angle made by the road surface with the horizontal is 90 degree. If that road is banked at 90 degree, it imposes lower limit on the turning speed. In previous subsection, we saw that for an unbanked road, there is an upper limit for turning speed. It means that for any other banking angle, that is 0, theta and less than 90 degree, the turning speed will have the upper limit as well as lower limit. So the upper limit will be given by this part and lower limit will be given by this part. So now I would like to explain how bank road helps the car make sharp turn. Let's start. So as I said earlier, suppose this is the part of circular track. So banking of road is nothing but, now we will see it like this. So this will be road which is going to follow the circular track. So the banking of road is nothing but, this will be inner edge and this will be outer edge. So you are raising this outer edge at a particular theta or at a particular height. So this process is known as banking of road. Let's start with the car on level. Let's say this guy is trying to make a left turn, which means the car makes centripetal force toward the left, and this force cannot be provided by weight or normal contact force, because this will be mg and this will be normal. So because these are the vertical force, so the centripetal force must be come from the frictional force that the road surface exert on the tire. So if you want to turn more sharply, you can use better tires with the better grip, so that you get a larger friction. But that's all you can do. So how does the bank slope help? So let's consider bank slope or a bank curved road. So this is vehicle on bank curved road. So that road is raised by angle theta. First notice that the normal contact is no longer vertical, is slanted, and therefore you can provide the horizontal component. Slanted means it has been tilted by a particular theta. So you can give horizontal component. So as normal is nothing but perpendicular to the surface of the road. So this is road. So perpendicular to the surface of road. So you can find normal as a normal by this line. So this will be normal, and from center of the gravity it will be mg. So here as normal has been slanted, so you can find horizontal component. So horizontal component will be like this and vertical component will be like this. So as normal has been slanted in a theta, so this will be also theta. Angle of inclination theta, then the normal contact force makes the same angle theta with the vertical, which means the vertical component of normal contact force will be given by n cos theta and horizontal component will be given by n sin theta. So here theta is made by this, that's why vertical component is n cos theta and horizontal component is n sin theta. So vertically the next path should be 0. So upward n cos theta to the downward mg. So we are going to find all the forces acting on it. So vertical forces will be given by, so which are the vertical forces acting on it? N sin theta and downward mg. So it will be given by n cos theta equals to mg. Let's consider it as the equation first. Now horizontally the net force, of course centripetal force, as it is performing circular motion, is given by n sin theta, so which is equals to, so horizontal force is given by n sin theta equals to mv square by r. So the frictional force will be given by this, Fs is given by this. So these are all the forces acting on this vehicle. These are the vertical forces. So this will be given by n cos theta is equals to mg, and these are the horizontal forces, n sin theta is equals to mv square by r. So when you are going to divide equation 2 by equation 1, what you will get? N sin theta divided by n cos theta equals to mv square by r divided by mg. So here mm will going to be cancelled, so you will get v square by rg, and in this case n and n will going to be cancelled, so sin by cos is nothing but tan theta, so you will get tan theta equals to v square by rg. So this is your relation for bank curve road. So basically by using bank road we are relying on normal contact force instead of frictional force to provide required centripetal force. In earlier example, the centripetal force was given by frictional force, and in this example, means in banked example, that necessary centripetal force is given by normal reaction of horizontal component. And there is actually no limit to how a big normal contact force is compared to friction, as long as bank curve road does not collapse. In fact, if you want to make a sharper the turn, you just have to increase the angle theta. So that angle you have to make. This type of example can be seen in the bridges in cities. If you could know that whenever there will be junction in bridges, so there is a slight increase in height. Or if you have ever visited water park, if you could remember that right, so you will find that in terms of curve, whenever there was a curve, there was a slightly change in the height of the outer edge. So that's why without changing the velocity you can easily take a turn. That's why bank curve road help us. So for bank curve road we got relation tan theta is equals to v square by rg. So from this equation v square will be tan theta rg, or you may write rg tan theta. So you got speed equals to under root of Rg tan theta. So this is relation for speed on a bank curve road. Most safe speed will be for a particular road r and theta are fixed. Thus, this expression gives us the expression for most safe speed, not a minimum or maximum speed on this road, as most safe speed denoted by Vs will be given by under root Rg tan theta. This is because of most of time r and theta are fixed for road. Next is that banking of road or banking of that angle, which is nothing but theta. So if you could see at this, or if you go through this equation, so you will get theta equals to tan inverse of v square by Rg. You have just shifted the tan to this side, so you will get theta is equals to tan inverse of v square by Rg. So this is banking angle. So while designing a road, this expression helps us knowing the angle of banking. Then let's talk about the speed limit, that it could be minimum or maximum. So let's consider the bank curve road. So it will be like this. So it will be like this theta, and consider the vehicle of mass m. So as we are considering the speed limit, so first of all consider the speed limit for speed. For speed v less than under root Rg tan theta. What does it mean? We have expression of v, speed is equals to under root Rg tan theta. So we will consider the value of speed less than this value. So as we have considered the example of this, now always remember one thing: whenever you are going to find the equation for an object performing any kind of motion, you have to consider all the forces acting on that body. So for speed limit, we are considering that speed is less than under root Rg tan theta, and that necessary centripetal force will require for the circular motion. So due to the surface of a road, it will exert force on the vehicle, so that force will be perpendicular, and that is nothing but normal. Due to gravitational force, mg will going to be there, which is vertically downward. This will be action force due to gravitational force, and this one will be normal. Okay, so now as we have discussed earlier, as this one is slanted by theta, so it will resolve into two components. First of all, horizontal component, and this one will be vertical component. So this would be theta. So this component will be given by n cos theta, and this will be given by n sin theta. So these are the vertical forces acting on the body. Weight mg acting vertically downward, and normal reaction acting perpendicular to the road. So as we have discussed, in the bank road, instead of frictional force, normal force will provide centripetal force. So as we are considering speed is less than this, What does it mean? That centripetal force will be less than normal component of normal, which is horizontal component of normal. So direction of frictional force will be along the inclination of road, and it will be upward. So the direction will be given by this, as again this is the resultant. So this force will be originated from this part. So this can be resolved into two components. It will be like this. First of all, this one resolve into vertical component, and this one will be resolved into horizontal component. If the road was like this, so frictional force will be given at this direction, so angle made by this, so that's why theta will be this one. Okay, so as theta is made by this, so this one horizontal component will be given by Fs cos theta, and vertical component will be given by Fs sin theta. Okay, clear with this? Again we will revise this term. This will be vehicle. Okay, so due to gravity, mg will going to be act vertically downward by Newton's third law. If there is an action, there will be equal and opposite reaction, and that equal and opposite reaction is nothing but here normal reaction, as the normal is slanted. So that normal can be resolved into two components, vertical and horizontal components. So theta is made by this, so that's why it will be given by n cos theta, and this one will be given by n sin theta, as we are considering speed less than this. And in case of bank road, that necessary centripetal force will be given by horizontal component of normal reaction, and that's why you are getting relation mv square by r, and due to the speed is less than this, so mv square by r is less than n sin theta. So you will get direction of friction will be upward, so that upward direction will be like this, Fs. Now at it has resultant friction, it also can be divided into two component, horizontal component and vertical component. So this one would be theta, so this will be Fs cos theta, and this would be Fs sin theta. That's it. Okay, so practice for this kind of example, because whole the derivation is based on this. So direction of Fs is directed along inclination of the road, that is upward. Now its horizontal component, and that horizontal component of friction is parallel to horizontal component of normal and opposite. Okay, that horizontal component of friction is parallel to horizontal component of normal and opposite in direction. So now what we have to do? We have to find separately vertical forces acting on the body and then horizontal forces acting on the body. If you could observe the diagram, you will find that vertical component balance the weight. What I am saying, that vertical component balance the weight. And what are the vertical component which are balancing the weight? Now you have to observe only which are acting vertically, so these are the horizontally. Okay, so you will find that only n cos theta and f sin theta are acting vertically upward. Okay, so write down that. You may write it like this, that vertical component balances the weight of vehicle. So the weight of vehicle balances by the component, and it is balances by component. Which are those components? That mg is balanced by which vertical component? N cos theta and F sin theta. So what is that? N cos theta and Fs sin theta. So how you are going to write in mathematical form? So mg is in vertically downward and these two are vertically upward. So write down on this side downward and on this side upward. So mg is vertically downward and these two are acting vertically upward. So that's why you can directly write Fs sin theta plus N cos theta, or you may simply write mg N cos theta plus F sin theta. That's it. So we have solved for vertical component. Now let's solve for horizontal component. So now while performing for horizontal component, neglect this vertical component. So you will find that horizontal component are N sin theta and F cos theta. So here horizontal component, what it gives? That horizontal component of normal reaction provide centripetal force. So how you are going to find that? Horizontal component provide centripetal force. Okay, so centripetal force is given by mv square by r equals to, now only we will focus on horizontal component. What are the horizontal component? N sin theta and F cos theta. Now you will find here that both are parallel to each other but opposite in direction. Okay, so centripetal force is in this direction toward the center. So what does it mean? N sin theta will be positive and it is away from the centripetal force, so this will be negative. So you can write N sin theta as a positive minus Fs cos theta. So this will be your second equation. I hope you have understood. Okay, so now let's move toward. So you got two equations. Your first equation was mg equals to N cos theta plus Fs sin theta, and second equation was mv square by r, which is centripetal force, equals to N sin theta minus Fs cos theta. Now what you have to do? You have to divide this equation by this equation. So you will get mv square by r equals to N sin theta minus Fs cos theta divided by N cos theta plus Fs sin theta. So as we are finding the minimum speed, so for minimum possible speed Fs, so for minimum possible speed Fs is maximum. If your friction will be maximum, your velocity will going to be decreased. Okay, which is equal to, as you know that Fs equals to mu s n. Okay, sorry, I have mistaken, divided by mg. So from this equation m and m will going to be cancelled, so you will get v square by rg equals to, now from this you can take n common. How you are going to take n common and why we are taking that n common? From this equation you will get mu s is equals to Fs by n, because we are able to know that coefficient of friction. So you will get, by this you will get n outside sin theta fs cos theta divided by n cos theta plus fs by n sin theta. By solving this you will get v square by rg equals to n, and will going to be cancelled. So sin theta minus mu s by n is nothing but fs by n is nothing but mu s. So you will get mu s cos theta divided by cos theta plus cos theta plus fs by n is nothing but mu s sin theta. Now what you can do, you can further simplify it by taking sin theta common. So you will get v square by rg equals to, you can take cos theta common. So you will get cos theta sin theta divided by cos theta minus mu s divided by cos theta. So here you are taking cos theta common, so it will be 1 plus mu s sin theta divided by cos theta. So as you know that sin theta by cos theta is nothing but tan theta. Cos theta will going to be cancelled. So tan theta minus mu s divided by 1 plus mu s tan theta. So that minimum speed will be given by rg tan theta minus mu s 1 plus mu s tan theta. So minimum speed will be given by under root of rg tan theta minus mu s divided by 1 plus mu s tan theta. That's it. Okay, so this is simple relation for minimum speed when vehicle traveling along curved bank road. So for mu greater than equal to tan theta, okay, so you are taking condition like mu s greater than equal to tan theta, v min will be 0. So this is true for rough road banked at a small angles. So this condition is only true when the surface is rough and the angle of a bank curve road is small. Okay, so what we have done in this case, this you have considered that speed will be less than rg by tan theta. Okay, now we will consider again vehicle on a bank road. So this will be vehicle banked by theta. Now this time you have to consider v will be greater than under root rg tan theta. So what we have to do, first of all we have to find all the forces acting on this body. So gravitational force acting on the body, which will result into the weight which is vertically downward. After that surface of the road exerting some kind that normal reaction, that opposite force. So it will be what? Normal. Okay, the normal has been slanted, so that normal resolve into vertical and horizontal component. So this will be resolved into vertical and horizontal component. So this will be n cos theta and this will be n sin theta. Okay, so as you are considering v is greater than under root rg. Now we have balances the vertical force. Now we are going to consider horizontal forces. So horizontal, what I said, vertical force will give information about weight, and horizontal force will give you information about centripetal acceleration. So the centripetal acceleration provided by normal reaction. So instead of writing in detail, now I will directly write the equation. I hope you have understood the earlier one, or if you didn't, then go through that. So vertical forces will be like this. So centripetal force will be given by mv square by r will be greater than n sine theta. And frictional force, the direction of the frictional force is directed along inclination road toward the downward. So this will be the direction of frictional force. Again, this frictional force resolve into two components, horizontal component and vertical component. So this will be theta. So it will be given by f cos theta, and this vertical will be given by f sin theta, or fs sin theta, fs cos theta. That's it. Let's revise this term again. What I said, there will be vehicle on a bank road. First of all, solve the vertical component, that is mg. So mg balanced by normal reaction n. So normal reaction is slanted, that's why it will be resolved into two components, vertical component and horizontal component. So it will be given by, due to theta, n cos theta, and this will be n sin theta. So as you are considering speed is greater than under root rg tan theta, so direction of frictional force is directed along the inclination, that is along the downward. So this will be direction of friction fs. So again it is resultant, so it will be divided into two component, vertical and horizontal component. So this will be theta made by frictional force. So this is given by fs cos theta, and this will be given by fs sin theta. That's it. Just practice for this. Okay. So vertical component balances, what I said, vertical component balances weight of the vehicle. So what are the vertical forces acting? So these are the horizontal. So just hide it. So you will find that vertical forces are only this. So now you will find that in this direction these two are working, and in this direction this is. So how you are going to write this equation? That mg, you are going to add downward forces and vertical forces, okay, upward force. So first of all add downward force and vertical force. So what you will get, mg plus fs sin theta, which is nothing but this part, will be equals to this. So n cos theta. So you will get mg is equals to n cos theta minus fs sin theta. So this one will be your equation number 1. Now let's move toward the horizontal force. What horizontal forces do? It provides centripetal force. So now neglect vertical forces. So what are the horizontal forces? These are the horizontal forces, okay, so which provide centripetal force. So centripetal force is given by mv square by r. So this both forces are, this both component are in same direction and along the centripetal force toward the center. So that's why you can directly add both the terms. So you will get n sin theta plus f cos theta. So from previous example, you know that what you have to do, you have to divide both the equations. So you will get mv square by r equals to n sin theta plus f cos theta or fs cos theta divided by mg divided by first equation n cos theta minus fs sin theta. Again you have to, what you have to do, you have to take n outside. So you will get mv square, sorry, m will going to be cancelled, so v square by rg you will get, and on this side you will get sin theta plus f s cos theta by n divided by cos theta minus fs by n sin theta. So for maximum possible speed, fs will be equals to mu s n. So from this equation you will get mu s is equals to fs by n. So when you are going to substitute in this equation, you will get v square by rg equals to sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Again what you have to do, take common cos theta from numerator and denominator. You will get v square by rg equals to sin by cos, so it will give you sin theta by cos theta plus mu s divided by cos theta 1 minus mu s sin theta by cos theta. So as you know that sin by cos theta is nothing but tan theta plus mu s divided by 1 minus mu s tan theta. So from this equation you will get v square is equals to rg tan theta plus mu s 1 minus mu s tan theta. So maximum speed will be given by under root of rg tan theta plus mu s 1 minus mu s tan theta. Okay. So this relation you got when speed will be minimum, this relation will be given by this, and when speed for maximum speed your relation will be given by this. Diagrams are easy, you have to just practice it. Okay, so if mu s equals to cot theta, what does it mean? If mu s is equals to cot theta, so cot theta is nothing but cos upon sine. When you are going to substitute cot theta, so v max will be equals to infinity, because this term will become, denominator will become 0. How? Tan theta is nothing but sine upon cos, mu s is nothing but cos upon sine, so cos and sine will be to cancel, 1 minus 1 will be 0, and anything divided by 0 is nothing but infinity. So you will get v max is equals to infinity. But maximum value of coefficient of static friction is nothing but 1. So when you are going to substitute 1, you will automatically get that 1 will be for theta is equals to 45 degree or greater than equal to 45 degree. So in this case v max will be infinity. So you got v min means minimum velocity rg under root rg tan theta minus mu s divided by 1 plus mu s tan theta, and maximum speed, you got relation for maximum speed as a rg tan theta plus mu s divided by 1 minus mu s tan theta. So when coefficient of friction will be 0, so this becomes 0, this becomes 0, so here it becomes 0, so this factor will become 0, so it will be given by v min will be given by under root rg tan theta only. Similarly when here also mu s will become 0, so this factor will become 0 and this whole factor will become 0, again you will get v max will be under root rg tan theta. So if you observe here, what you will find that you are getting same thing, that v min equals to v max will be equals to V under root Rg tan theta, which is safest speed on a bank. So what is that? This is safest speed on a bank curved road. So as don't take help of friction. At this, speed of frictional force is not needed to provide necessary centripetal force. There will be a little wear and tear of a tire if vehicle is driven at this speed on the bank road. So here V is called optimum speed, and this optimum speed depends upon radius of curvature, acceleration due to gravity, angle of banking, and it is independent of mass of the vehicle, as there is no any kind of mass factor. Thus heavy or light vehicle speeds remains the same. So we have almost done. Just practice it. So what we have to remember, in horizontal curve road, centripetal force will be given by frictional force, and in case of bank road, centripetal force will be provided by horizontal component of n sine theta. Okay, horizontal component of normal direction. That's it. That things we have to remember. Then you have to solve vertical components and horizontal component. Okay, all the best.